Labguy here. I hope you enjoyed those 8 very improved images coming from the Philo monitor. First thing this morning, I sat down with the board and went over it with a fine-toothed comb, and sure enough I found 2 wiring errors. The first was that I had missed a ground on the D to A converter. This was causing the video levels to just be wildly all over the map, from extremely low, like in the dark pictures, to ridiculously high, which was making the geometry of the monitor actually change. So I'm not going to analyze why it did that because it's irrelevant. The video signal is now set at 1 volt. In fact, it goes 0 to -1 volt. And it turns out, by good luck, the monitor wanted negative video to produce a positive image. So, lucky Labguy. The second flaw in the picture, which gave the images kind of a gritty look that was driving me crazy, turned out to be the address lines to the video memory, to the image memory. Address line 0 and address line 1 were switched. So the cadence of pixels coming out was 0, 2, 1, 3. So this amounts to every other pair of pixel columns were switched. If that was in the design spec, I would still be scratching my head as to how to do that. I probably would have fixed it in software. So that fixed that. The pictures are now square. The geometry is linear, as you saw, and the monitor is behaving itself. I would have made this video yesterday, except that this monitor is from the 1970s, and some glue had given out in the deflection yoke, and it had come into 2 parts. The clamp that holds the deflection coils to the plastic body were separate, and so that the deflection coils were free to rotate, and every time I moved the monitor, the picture went crooked. So I had to put some glue on that, and it took all day yesterday to cure. It's good to go now. I promise this is the last of the sync generator episodes. We will be going back to the camera very, very soon. The next phase is to build the deflection drivers for the deflection yoke and install those in the camera case. We will look at the camera itself as it is at the moment, as I have not shown it for many episodes, and I'm sure many of you who have signed up since the beginning would like to see that. The last time I worked on the camera, I was getting an image from it on the oscilloscope. So at that time I was driving the deflection yoke from 2 audio signal generators, which is far from ideal. But it does scan. You are able to see the image when I do that, as you'll see right here. That's a picture of Farnsworth. That was a little slide that I had taped to the front of the tube and shined a high-intensity LED into the camera to produce that image. So the goal, of course, is to get to the point where we have a lens on the front of the camera and we can actually take live pictures with it, even if it might require very intense lighting. I don't know yet how that's going to work out. But we will have the camera tube running with linear sawtooth scan and at this 15 frame per second rate and displayed on this monitor. So let's go now and take a look at the camera head itself and where it is at and what the eventual plan will be. Let's review the basic PhiloCam project as it was before I began working on the sync generator project. As you can see, we have the metal box that houses the project, the high voltage power supply, which is based on a gamma high voltage module which converts 12 volts to 3000 volts, of which I use 2000 volts. All the connections to the image dissector tube, which lives inside this deflection yoke, which was originally intended for a Vidicon tube. This image dissector tube is called a Vidissector because it was designed to use this yoke. This is an actual 2-inch image dissector tube. It has the photosensitive target where the image is focused. It lives inside of a coil like this, only much larger, which has a collimating field of lines running the length of the tube, and the 2 pairs of deflection coils to move the electrons back and forth and up and down. This region is called the drift tube. Back here is a multiplier stage, like a photomultiplier tube. And in this tube, the image of light, it strikes the photosensitive surface and creates an identical image in electrons within the tube, which, because of the parallel magnetic field, travels back to the back wall of this tube. Now there's a series of rings in here which accelerate the electrons. In the back wall, in the center, is a pinhole. At that pinhole, the entire electron image is swept back and forth over the pinhole. That's how the scanning is done in a dissector tube. That's what this deflection yoke will do with this tube. After the electrons from the image have passed through the pinhole, which is like sampling the same size spot on the face of the tube, it's scanned, it's sent to a multiplying stage, a set of diodes, which rely on secondary emission, that when an electron strikes the first plate, it knocks off 2 or more electrons, which are drawn to the following plate, which knock off 2 or 3 electrons, and this cascades down through anywhere up to 10 of these stages. This tube has 11 stages in it, I believe, 10 or 11 stages. And each stage is 100 volts more positive than the previous stage. This is my original XY deflection amplifier, and there were 2 issues with it. One, it has an upper bandwidth limit of about 3 kilohertz, so we couldn't scan faster than 3000 cycles. And the 2 deflection coils in this deflection yoke are not equal. The amplifier is 2 equal amplifiers. These are not equal coils, so there was a discrepancy in that respect. So this amplifier was used to create this image of Philo Farnsworth from this tube. That was done by taping a slide to the face of the tube and lighting it with an LED from this end. I'm currently showing the camera with a camera lens on it because I'm optimistic that we will be able to focus an image in there, and in just short order we should be able to get video out of the tube when the scanning generator is complete. The scanning generator will be built on this board, and it will be positioned right here, standing on edge. And this is the sync board, which you're already familiar with, and it will be positioned up here, standing on edge. So the 2 boards, the sync and the deflection, will be right here. And they're conveniently located near the connections to the deflection yoke. And that summarizes the construction of the PhiloCam image dissector television camera. So that is the continuation of the PhiloCam project up to this point. Thank you for watching. I'd like to say welcome to all of my new subscribers. Thank you for signing up. The more the merrier, right? And if you like this video, give it a thumbs up. Don't forget to give it a thumbs up. And subscribe, tell your friends. Everyone must know someone else who would be very interested in a subject like this, because many people have never seen anything like this, And as far as I know, these are the only videos on YouTube addressing a system of this type. So until next time, Labguy out.